we will first see one small topic, and then after we will start with the problem discussions. So let's say let's say if we have a simple NOT gate. So if we have a simple NOT gate like this, so what is the alternate representation of this particular NOT gate? Is the alternate representation of this NOT gate is this. Okay. So you can keep the bubble at the output, or else you can keep the bubble at the input. Okay. So this is the alternate representation of your NOT gate. Okay. Now, what may be the alternate representation of your AND gate? Let's say this is A and this is B. Y is equal to A dot B. Now, what may be the alternate representation of your AND gate? And followed by your OR gate. So, what may be your alternate representation of your OR gate? A, B, Y is equal to A plus B. And if we have a NAND gate, then what may be the alternate representation of this NAND gate? That is Y is equal to A, B bar. And if we have a NOR gate, then what may be the alternate representation of this NOR gate? A, B, Y is equal to A plus B bar. Yes. So what may be the alternate representations of your AND gate? So how to find out the alternate representation of your AND gate? Yes. So what we can do, we can apply. So what we can do is we can apply the De Morgan's law. So this simply can be written as your bubbled input NOR gate. Okay. So that is Y is equal to A bar plus B bar the whole bar. Okay. So that is it will become Y is equal to A B. Okay. And this A plus B can be written as your bubbled input NAND gate. Okay. So that is nothing but Y is equal to A bar dot B bar the whole bar. Okay. And this NAND gate can be written as bubbled input OR gate. A, B, Y is equal to A bar plus B bar. Okay. And this particular NOR gate can be written as bubbled input NAND gate. Sorry, bubbled input AND gate. A, B, Y is equal to A bar dot B bar. Okay. So this is the alternate representations of this particular gates. Okay. Is this clear? So whenever if you see any bubbled input NAND gate, you can replace that with OR gate. And whenever you are going, if you are seeing a bubbled input OR gate, you can replace it with a NAND. You can replace it with a NAND gate. And if you see a bubbled input AND gate, you can replace it with a NOR gate. Okay. So is this clear? Shall we move forward? Shall we start with our problems? Yes. So this is the first problem. So please take your time, take 2 minutes of time and solve this, and please let me know the answer. Okay. Yes. What is the answer we are getting for this particular question? Anyone got the answer? Okay. So let us see the approach how to solve this particular question. So we can apply the concept which we have discussed now. Okay. So what I'm going to do is, so this is my first gate, second gate, and third gate. Okay. So this is my fourth gate. So can I say my fourth gate is nothing but my bubbled input NAND gate. Okay. So here fourth gate is my bubbled input NAND gate. My fourth gate is nothing but my bubbled input NAND gate. Okay. Bubbled input NAND gate. So what is bubbled input NAND gate equivalent to? So bubbled input NAND gate, where it is this one, it is equivalent to an OR gate. So can I replace this NAND gate with my OR gate? Yes. So since it is my bubbled input NAND gate, it is equivalent to OR gate. Can I replace it with my OR gate simply? Yes. Okay. So what I'm doing, I'm just simply removing the bubbles, and I'm simply replacing the NAND gate with my OR gate. So from this I will easily get the equation A B C D E F. Okay. So if I get this, my final answer will be AB plus CD plus EF. This is my final answer. That is option C. Sorry, option B. So is this clear for everyone how to solve this particular question? Is it clear? Anyone having any doubt in this one? Is the approach clear for everyone? Yes or no? Please let me know in the chat box. Yes. Okay. So this is how we are going to solve this particular question. Okay. Now let us see one more question. So in this following circuit, they are asking the output Z. Okay, take your time, take 2 minutes of time and solve this, and please let me know the answer. Okay, option A, no? Okay, let's see. So how to solve this one? So here also we can apply this particular concept which we have seen previously. So what we can do here, so this is one NOT gate, that means this is one bubble present here, okay, and here also one bubble is present here. So what is your bubbled input NAND gate equivalent to? It is nothing but your OR gate. Okay, it is nothing but your OR gate. So you can replace this whole circuit as, so you can simply replace your whole circuit as simply AND gate and followed by OR gate, and simply this NAND gate will be converted to an AND gate. Okay, and NOT gate will be removed, and this NAND gate will be converted into an OR gate. Okay, this is how we can replace our circuit. And A, B, C, D, E. Okay, here we are going to get AB, C plus D, C plus D into E. So that is nothing but AB plus C plus D into E. Okay, so this is our equation. So that is option A. Is this clear? The approach, is it clear? Now take your time, take 2 minutes of time, solve this, and please let me know the answer. Yes. So let's see the answer how to solve this. So this is your NAND gates. So this is nothing but your bubbled input NAND gate. So this is nothing but your bubbled input NAND gate. So you can replace this NAND gate with your OR gate. Okay. So that the whole circuit will be converted to this type. So we will have M and Q. We will have one AND gate and one more AND gate with some inputs, and one more AND gate with some inputs, and this outputs will be connected to an OR gate. Okay, so why we are converting this? Because if you do this with having your NAND gates, you will get the answer, but it will be some little bit complicated because you will have bars, right? So you should apply De Morgan's law again, you should solve it. Okay, it is time taking. So you can identify which gate can be converted into a simpler gate, and you can solve the equations. Okay, so here we are going to get M, N and Q. Okay, here am I right? M, N, Q, exactly. And here I am going to get M, N bar, Q. Here it is the second gate. I am going to get M, N bar, Q, and in the first gate I am going to get M and Q, and from the third gate I am going to get M bar, N, Q, M bar, N, Q. Okay, so let us solve this. M and Q plus uh, M n bar Q, M n bar Q plus M bar NQ plus M bar NQ. Okay, here NQ is common, so M plus M bar is equal to 1. So NQ, so what are the options which are present? Okay, so NQ plus M n bar Q. Okay, so if we take Q common, it will become N plus Mn bar. And what is the options present? M into Q plus N. Okay, so this is nothing but Q into M plus N. So this is the answer I am getting, Q into M plus N. That is okay. Q into M plus N is option D. Option D I am getting. Are you getting the same thing or any different answer? q into m plus n, right? Try solving this one. Take 2 minutes of time and solve this. Okay, I will also solve parallelly. Okay, so here I'm going to get a bar, and here I'm going to get a b bar, and here I'm going to get b c bar, and here I'm going to get c bar. Okay, and I'm going to add everything. So a bar plus a b whole bar plus bc whole bar plus c bar. Okay, so if I apply De Morgan's law in these two terms, then it will become a bar plus b bar plus b bar plus c bar plus c bar. A bar plus a bar is 1. Sorry, a bar plus a bar is a bar, and b bar plus b bar is also b bar, and c bar plus c bar is also c bar. So a bar plus b bar plus c bar is the answer I am getting. Everyone getting the same one? Same one? Any different answers? Please check this: a bar plus b bar plus c bar. And also I will get one more answer, that is nothing but ABC whole bar. So two answers I will have. Please confirm this. Is it clear? Okay. I will have two answers: a bar plus b bar plus c bar, and also ABC whole bar. If there is any multiple choice question, then you might tick. You might choose both options. Okay. Yes. Next, we have given an expression x plus y into x plus y bar into x bar plus y, and they are asking it is equivalent to. Okay, so you can also try with me parallelly. Okay, I will also doing this question parallelly. You can also try on your own. Okay, so how to do this? This is x plus y into x plus y bar into x bar plus y. Okay, and we can multiply these two terms. So what we are getting: x plus xy bar plus xy plus y into y bar is 0 into x bar plus y. Okay, so that means x into x bar is 0 plus x into y is xy plus x into x bar is 0, x into x bar is 0, and x into y is xy, and x into this is 0, and we will get one more 0, and this into this is also 0, and followed by xy plus 0. So my final answer is simply xy. Next, so in the following circuit, they are asking to find out the output x. Okay, so try this one and let me know. Okay, I will also do try solving this parallelly. So this is my first output, second output, and third output. So output of my first gate is A XOR with B, and output of my second gate is A plus B bar whole bar, and output of my third gate is that I should find out. Okay, so what I'm getting: A XOR B into A plus B bar the whole bar. Okay, now if I expand this term, it is A bar B plus AB bar, and if I apply De Morgan's law here, so it is A bar dot B. Okay, and if I multiply these two terms, then A bar B into A bar B is A bar B, and AB bar into A bar B is 0. So my final answer is A bar B. Okay, everyone getting the same answer? Now solve this question and please let me know in the chat box. Yes, so let me solve this parallelly. So y, which is nothing but A XOR with B dot C the whole bar. Okay, this is the equation we are getting it. Yes. So if I apply De Morgan's law, that is A XOR with B bar plus C bar. Okay, and that is y is equal to A bar B bar plus AB plus C bar. A bar B bar plus AB plus C bar. So this is my final answer. Can I perform any further simplifications on this? This is my final answer. Okay, I cannot perform any further simplifications on this. So this is my final output. So they are asking to find out the output Z. So I'm also doing this parallelly. So the output of your OR gate will be A plus A bar. Okay, the output of your OR gate is A plus A bar, that is 1. Okay, now the OR output of your AND gate is nothing but A into 1 into B into C, that is A, B, C. Okay, are you getting the same one? Solve this question and please let me know in the chat box. Okay, so let's see how to solve this. So first output is AB, and the second output what we are going to get, this is output of your first AND gate, and from OR gate you are going to get B bar plus C. This is your first OR gate. Okay, and from your second AND gate we need the output, that is nothing but AB into B bar plus C. Okay, that is nothing but A, B, C. So they are asking for output Z. Okay, I will solve this parallelly. So you can also do this parallelly. So output of your OR gate is nothing but A bar plus B bar the whole bar, and that is nothing but A, B. Okay. Now, what is the output of your AND gate? That is output of your AND gate is A, B, C. Okay. Everyone getting the same thing? Now, this question there is a small mistake here. It is A plus A bar B plus A bar B bar C plus A bar B bar C bar D plus A bar B bar C bar D bar E. Now try this. So this is a very famous question in many exams, in many competitive exams. We can see this exam. We can see this particular question. Okay, I will also start solving parallelly. So you can take these two terms common. So a plus a bar, e plus e bar into a plus b plus a bar b bar c plus a bar b bar c bar d plus a bar b bar c bar d bar e. That is nothing but a plus b plus a bar b bar c plus a bar b bar c bar d plus a bar b bar c bar d bar e. And if I take what can I take common? Yeah, so if I apply distributive law in these two terms, then I will get a plus b plus a bar b bar c plus a bar b bar c bar d, or else what can I do? This is nothing but a plus b plus, if I take only this term c plus, sorry, I can simply take a bar b bar common now. I can take a bar b bar common, a plus b plus a bar b bar if I take common, then c plus c bar d. Okay, and followed by a bar b bar c bar d bar e. Okay, so this is nothing but c plus d, a plus b plus a bar b bar uh, c plus a bar b bar d. Okay, plus a bar b bar c bar d bar e. Now if I take a plus b plus. If I take a bar b bar common in these two terms, then a bar b bar into c plus c bar d bar e plus a bar b bar d. So what I'm going to get, a plus b plus a bar b bar into c plus c bar d bar e is nothing but c plus d bar e plus a bar b bar d. Okay. So what you're going to get, a plus b plus a bar b bar into uh, a bar b bar c plus a bar b bar d bar e. A bar b bar d bar e, taking common and using Boolean law, same approach. Exactly. Okay. A bar b bar d bar e plus a bar b bar d plus a bar b bar d. Okay. So what we can take common, a bar b bar we can take common, or we can take common from these two terms, a bar b bar. Then a plus b plus a bar b bar c plus, if I take a bar b bar common, then I will get uh, d plus d bar is 1, d plus d bar e, that is only d plus e. Okay, that is a plus b plus a bar b bar c plus a bar b bar d plus a bar b bar e. Okay. uh, so what I'm getting some different answer now. Okay, if I add these two terms, then my a term will be eliminated, a plus b bar c plus a bar b bar d plus a bar b bar e. Okay. And plus b. And if I add b in these two terms, if I apply distributive law, then a plus b plus c plus a bar b bar d plus a bar b bar e. And if I again apply a distributive law, this a will be eliminated, a bar will be eliminated. So, and again if I apply b, if I add this b with these two terms, b will be eliminated. Okay. So finally you are going to get a plus b plus c plus d plus e. Okay. Is this clear for everyone? Yes or no? Next. So solve this. Y is equal to a into b plus c into eb plus ac the whole bar. So take 2 minutes of time, solve this, and please let me know the answer. Yes, so I will also try this parallelly. So y is equal to a into b plus c into ab plus ac the whole bar. Okay. So this we need to solve. Now what I can do, I can apply De Morgan's law here. So y is equal to a into b plus c into if I apply De Morgan's law, ab bar dot ac bar. Okay. So y is equal to a into b plus c into this, ab bar can be written as a bar plus b bar into a bar plus c bar. Okay. And this is y is equal to a into b plus c into, if I multiply these two terms, then I will get a bar plus a bar c bar plus a bar b bar plus b bar c bar. Okay. Now, so what is the equation I'm getting? Y is equal to a plus b into, sorry, a into b plus c into a bar. A bar plus a bar c bar can be written as a bar plus c bar. Okay. A bar plus c bar plus a bar b bar plus b bar c bar. Okay. And if I multiply this entire thing, y is equal to a into b plus a bar c bar plus c into c bar is 0 plus a bar b bar c plus c into c bar is 0. Okay. And if I multiply this term, then y is equal to ab plus a into a bar is 0 plus 0 plus A into A bar is 0 plus 0. So my final answer is AB. Okay. So y is equal to AB bar whole bar dot A bar B whole bar. AB bar whole bar into A bar B whole bar. So for this they need the reduced expression. So I'll also try parallelly. So it is nothing but A bar plus B into A plus B bar. Okay. So there is nothing but A bar into A is 0 plus A bar B bar plus AB. Next, so xy bar plus x bar y is equal to z. Then xz bar into x bar z. They are asking. Okay. So this you can take as your assignment. Simple task. You can take this and please let me know in the group. Okay. Will you try this one? Now. So in the following circuit, for which of the following input combinations the output is 1? So we need to find for which combination of inputs your output is becoming 1. This is what we need to find. Okay. Try this one and let me know. Yes, so I will also try this parallelly. So what we need f is equal to 1. Okay. So for your output of your AND gate should it should become 1. Then what should be your inputs? It should be 1 and 1. If your output of your AND gate it should be 1, then your input should also be 1. Now here, if your output of your NOT gate, if it should be 1, then definitely your input of your NOT gate should be equal to 0. Okay. And input of OR gate is 1 here. Okay. And here your output of OR gate should be equal to 0. Here your output of OR gate should be equal to 0. Okay. And here also your output of OR gate should be equal to 1. Here output of your OR gate should be equal to 1. That means in this particular line there may be two combinations. It can be 0 or it can be 1. Let us assume it is 0. Okay, let us assume that it is 0. Now that means here we are getting 0. At this particular point it is 0. That means your this particular point is 0. Okay, then definitely this A should be equal to 0, so that your output of OR gate will be equal to 0. Okay, so A is equal to 0 here. Now A is equal to 0 is fixed. Now your output of NOT gate is 0, that means input of NOT gate is 1. Then definitely B should be equal to 1. So that is A is equal to 0 and B is equal to 1. Please check this and please let me know, are you getting the same answer or any different answers? Please let me know in the chat box. Option D. A is equal to 0, B is equal to 1. Exactly. Is this clear? The analysis is it clear for everyone? So here we have a diode. So on the diode, on the positive terminal we are having high voltage and this is negative voltage. Okay. Try on your own and please let me know. Option D. Okay. So let's see how we are getting option D here. So here the input of your the positive terminal of your diode, it is 5 and and your LED should glow. Okay, so that means here it should be 0 and here it should be 0 present. So output of your NAND gate it should be equal to 0. That means input should be equal to 1. Okay, that means output of your XOR gate should be 1 and output of your AND gate should be equal to 1. If your output of your AND gate should be equal to 1, then definitely input should be equal to 0. That means switches should be open. Okay, and if your input of your AND gate is 0, that means here you are going to get 0. And what is the another input? This is your XOR gate. Okay, and what is the other input? So if both the switches, this is 0 and 0, sorry, this is 1 1 1 and this should be equal to 1. That is both the switches should be closed, then only your output of your AND gate will be equal to 1. and XOR gate. So this is 1. And what is the other input? What is the other input? It is also 1. It is also 1. Okay. Then definitely your XOR gate output will 0. If your switch is closed, then your XOR gate output is becoming 0. Let's say if switch is open, then AND gate output is becoming 0. Okay. So that's why if switch is on or switch is off, your LED is not going to turn on. So it's option D. It's option